In this video, I'm going to go ahead and walk you through how you can find the line tangent to the graph, how to use that tangent line to approximate a particular value, and then how to determine whether or not that approximation is an overestimate or an underestimate. So in part A, we're asked to go ahead and find the equation of a line tangent to the graph. The line that we are trying to find, we can go ahead and use y equals, in this case, our function is named n, so it's the derivative of n at the particular a value that we're interested in. In this case, it's going to be 1 times x minus 1 plus 0. So this is my x value, and this is my y value given and my coordinate point. And so to figure out the derivative at 1, I have to take the derivative of n of x. N of x is ln of 2x minus 1. So the derivative of n is going to be 1 over 2x minus 1 times 2. So the way that I find the derivative is by using the chain rule. So the derivative of ln of x is 1 over x, but it's with respect to my inner function. So that's why you don't see me write 1 over x. I write 1 over 2x minus 1 because it's the derivative of f with respect to g times the derivative of g. So times the derivative of 2x minus 1 is 2. To simplify that, that's going to be 2 over 2x minus 1. I can now go ahead and evaluate that derivative at the value 1. So 2 divided by 2 times 1 minus 1 is going to be 2 divided by 2 minus 1, which is going to be 2 over 1, 2. So the derivative of n at 1 is 2. So my updated equation is going to look something like this. This is going to be my tangent line. 2 times x minus 1. I'm not going to put plus 0 because I don't need to. So now I'm going to go ahead and use that approximation, or excuse me, use that tangent line to find the approximation. So what I want to try to find is the value at of n at 1.25 using this tangent line. So 2 times 1.25, actually let me go and write it this way. I'm going to go ahead and say this is approximately 2 times 1.25 minus 1. When I simplify that 1.25 minus 1, it's going to be 0.25. 2 times 0.25 is approximately 0.5. So this is my approximation for the value of n at 1.25 using the tangent line. I now need to determine whether or not that approximation is an overestimate or an underestimate. And the way that I do that is by looking at the second derivative. If the second derivative is greater than 0, I know that my function is concave up, which means that my line would be, my tangent line would be underneath, giving me an underestimate. Or if the second derivative is negative, my function is concave down, which means my tangent line would be above the curve, making this an overestimate. So again, n of x is given by the equation ln of 2x minus 1. We found the derivative in part A, and the derivative of that was 2 over 2x minus 1. So to find the second derivative, I'm going to use quotient rule. So my lower function, low, d high, derivative of 2 is 0, minus high, derivative of 2x minus 1 is 2. So low d high minus high d low, square the bottom, and away we go. Anything multiplied by 0 is going to be 0 here, and then 2 times 2 is going to give me 4. So the second derivative is given by the equation negative 4 over 2x minus 1 squared. What I need to do now is find whether or not the second derivative is positive or negative, so I can determine whether or not I'm concave up or concave down. The point that I'm interested in is the value at, what were we given? At 1. So we're investigating what's happening near 1. So I go ahead and I plug in 1. 2 times 1 minus 1 squared is going to be a negative 4 over, let's see, 1 squared. And in this case, it's going to be negative 4. So since the second derivative is actually less than 0, when we are looking at x equals 1, that means that my function n of x is concave down, making our estimate an overestimate. Again, since we're concave down, my line is going to be above the curve. And we can actually verify that in part D by taking my equation n of x and verifying that when we plug in our tangent line, it actually sits above that function. So let's go ahead and plug that in. So I can go ahead and plug in my function, ln of 2x minus 1, and 2 times x minus 1. You can see that my tangent line fits nicely along that curve, and it verifies that yes, indeed, I am concave down, which makes my estimate in part B an overestimate. So I'm going to go ahead and add that here. This sort of a picture summarizing our work. So this represents my function n of x, which is ln of 2x minus 1. My green line is what I found in part 1, or part A. So that's 2 times x minus 1. And you can see I was estimating 1.25. So 1.25 is approximately right here. And so you can see that tangent line just slightly overestimates that value, which is around 0.5.